Hi, good morning, good afternoon, whatever it may be. I want you to have a look at this image that you can see on the screen. I want you to think, how would you describe it? And linking back to what we did last lesson, where on our long profile would you expect to find an image or a river that looks like this one? So the description of this river, you can see it's got quite a small river, quite narrow, not very deep. It's got quite steep valley sides. Therefore, we would expect to find it somewhere in the upper course, so somewhere near where the river starts, near its source. So what we're going to look at in the next hour is we're going to look at erosion or landforms. So we're going to look at the landforms along a river that are made by erosion, so made by that wearing away of the bed and banks, changing the shape, changing the size. In terms of where we are within our topic, we are now down here looking at river landforms, erosional landforms, and the ones we're going to focus on are something called interlocking spurs, waterfalls and gorges. So at the end of last lesson, I gave you a little review piece and a little bit of a quiz. There will be another one at the end of today as well. So what you can see here, this is your V-shaped valley, and it's called a V-shaped valley because it looks like a V, not very imaginative. As the V-shaped valley flows, moves, it zigzags, look. And because it zigzags, you get these sticky out sections, and we call them interlocking spurs. Got to imagine they're like your fingers. If you lock your fingers together, cross them over into like a V, that is what these interlocking spurs look like. But these landforms, they're made by erosion. So a bit of a recap, thinking back, what are those 4 different types of erosion? So there's 4 different types. You have hydraulic action, abrasion, attrition, and solution. So those 4 types of erosion are what creates our V-shaped valley and also our interlocking spurs. Now we're going to draw some diagrams and we're going to write an explanation as to how these landforms are actually created. So I suggest you do 3 boxes. I think you could do this over a full page actually. That should work. So in your first box, you're going to draw and write stage 1. So in stage 1, you can see that you have quite hard rock. This is up right near the start of the river, near the source. And what happens is that river, that stream, it erodes down vertically through that hard rock. And what it does is it makes that steep sides, those steep sides to the river valley. And because up near the start of the river, there's not much water in it, the discharge is low, the volume is low. And that means that the river has to use most of its energy to flow, to overcome the force of friction. And any energy that it does left over, it uses that to deepen the channel through vertical erosion. And the main type of erosion up there is hydraulic action. So that river erodes downwards, vertically, creating this steep valley. But that's not very stable. So what tends to happen is weathering, things like freeze-thaw weathering or biological weathering, they actually break down the sides of the valley. And as that breaks down the rock on the sides, that then falls into the river channel itself. And what that then does is it causes the valley to become more of a V shape. Our final stage, so stage 3, this is where the river takes that winding path. And it takes a winding path because it hits harder obstacles that it can't go through. So what it tends to do, it takes the easier route and it goes around it. And as a result, you end up with sections of the valley sticking out, creating these interlocking spurs. And your river takes a zigzag path through the middle. And all these interlocking spurs it's just the V shape of the valley in different locations. That's it. But what's important to remember is all of this is taking place up in our mountainous, our hilly areas within the UK. And usually the rock there is quite resistant, it's quite hard, so it might be something like granite or something like slate possibly, and it doesn't erode very quickly. It's quite resistant to that erosion. So a river going from stage 1 all the way to stage 3, that can be thousands, hundreds of thousands of years for that process to take place. So I'd like you to draw yourself 3 simple diagrams, stage 1, 2, 3, in pencil. Add some labels and then give a description of what it's like and an explanation as to how these V-shaped valleys and these interlocking spurs are formed. So if you have a look back at this image, the one we looked at the start of the lesson, where on the diagram can you see those interlocking spurs? So where are those interlocking spurs on that diagram? They are here. Each one of those red lines shows the interlocking spur sticking out and your river having to zigzag through the middle. Okay, our next erosional landform. So what is it and how do you think it has been made? Of course, this landform, it is a waterfall. And this landform, it has been made by the river eroding. Remember, these are all erosional landforms, so they're all made by erosion. So waterfalls will only form if you've got very specific conditions. And what you need to have is you need to have a harder rock on top of a softer rock. And the reason you need that is because the river flows over the harder rock, it then hits the softer rock and it erodes the softer rock much quicker. Things like hydraulic action, things like abrasion, what they do is they erode that softer rock and they create this overhang of harder rock. And that can't continue, it becomes unstable. That overhang, it will collapse. It will collapse into the waterfall. That gives the river more ammunition, more rocks to erode with. So through abrasion, it actually starts to make this plunge pool, this very deep section of the river. And you start to get these pebbles, stones and boulders building up within this very turbulent water. And that process, it carries on, it keeps happening. And so your waterfall, what it will actually do, it will retreat upstream. So it would have used to be here, but because of erosion, because the overhang collapsed, it moved back. More erosion, overhang collapse, move back. That keeps happening over time, hundreds of thousands of years, millions of years in some cases. So this is what you get. You get your waterfall leaving behind a very steep-sided valley, and that's what we call a gorge. So a valley created by a waterfall retreating, it's called a gorge. And this is a very famous waterfall up in northeast England, and this is called High Force Waterfall. So we're going to draw some diagrams and write some explanations about how these landforms are actually created. So step 1. So you can draw this diagram in pencil and you can do your written explanation in pen. So they form in the upper course of the river, remember, where you've got erosion, where your hard rock overlies your softer rock. Falling water and rock erode the rock below the waterfall, creating that plunge pool, that deeper section. Remember, this is your hard rock, this is your soft rock. So that soft rock, that becomes undercut, hydraulic action, abrasion, they're the dominant types of erosion. Corrosion, we'll use the term abrasion there. That creates a deeper plunge pool and a larger overhang. Step 3, that hard rock overhang here, that will collapse into the plunge pool because it's not supported. Imagine you're sat in a chair and one of the legs broke on the chair would collapse. That's like what's happening here. The hard rock overhang is not supported, therefore it collapses into the plunge pool. And finally, 4th stage, the erosion continues and the waterfall retreats upstream, leaving behind that gorge. So make sure you've got yourself 4 diagrams, 4 explanations as to how that waterfall is formed and how it changes over time. So this is probably a little bit harder now. I don't want you to draw the diagram. What I would like you to do is write the numbers 1 to 7. And then for each number, I want you to write down what you think it is showing. So for example, it could be a label of a type of erosion or a type of rock. It could be a feature, for example, a plunge pool, an overhang. But I want you to write down what you think is happening in each of those boxes. When you're ready, you can press play and I will reveal the answers. Of course, if you want to draw it, you can. So number 1, that is your harder rock, your more resistant rock. Number 2, that's our softer rock. Number 3, if you labelled that as your plunge pool, I'll let you have it. But you can also have the undercut of the softer rock by hydraulic action and abrasion, those types of erosion. Number 4, that is your overhang, so your hard rock overhanging that will eventually collapse and your waterfall will retreat. Number 5, that's your turbulent water. Number 6, you've got your pebbles, your stones and your boulders. And number 7, you've got that former position of the waterfall, which is now retreated and formed a gorge. So if you need to change any of your labels, any of your numbers, please do. And if you want to draw the diagram, you're more than welcome to, but you don't have to. So now I've got a question I want to answer, and I want to answer it using our key terms and our triggers. So the question is, why is a waterfall only a temporary feature on a river's course? So why is a waterfall only a temporary feature on a river's course? So the key terms I want you to use: erosion, hydraulic action, abrasion, plunge pool, overhang, hard rock, soft rock. And the triggers, because this means that, leading to, as a result. And it's because you need to explain. You can't just say hard rock on top of soft rock. You've then got to elaborate, you've got to further develop, say, because you've got hard rock on top of soft rock, what then happens? Then what happens? Then what happens? But this question is specifically asking, well, why is that waterfall? Why is it only a temporary feature? What happens to the waterfall? Hint, where does it go? What does it leave behind? So have a go at answering that. Once you're ready, press play and I'll read you through an example answer. So a waterfall is only a temporary feature on a river's course because it is made by erosion, mostly hydraulic action and abrasion. Where hard rock sits on top of soft rock, the softer rock is eroded to create a deep plunge pool. Eventually, the hard rock sticks out as an overhang. This is unsupported, therefore it collapses into the plunge pool and the waterfall retreats upstream. As the waterfall retreats upstream, it eventually turns into a gorge. Therefore, the waterfall is only a temporary feature because it is always retreating upstream. Okay, now we've got a few map skills. You have a picture of high force waterfall and the red arrow shows you where it is. So there's high force waterfall, it's here on the river. Just to give you a hint, the river is flowing in this direction. So it's flowing across your map from the west to the east. On this map, the vertical lines always go from north to south. So north is up, south is down, east is to the right, west is to the left. So first thing I want you to do is I want you to work out, where was the photographer stood when he took this photograph? Bear in mind safety, he can't be stood in the middle of the river as he's taking it. But where was the photographer stood when he took this photograph? And in what direction do you think he was facing? So the photographer was stood in grid square 882.285. So that is our 6-figure grid reference. If you had something like 883 or 284, 286, something like that, you can have it. So 882, this line here is 88. So this will be 880, 881, 882. I then need to go up the stairs to get my second part of my 6-figure grid reference. So this grid square here, this line is 28. So this will be 280, 281, 282, 283, 284,